Hello everybody, I'm Lara from Proxima, and today I'm going to host this AI integration working group. Okay, wait a minute. Um, as a recap, on the last working group, we had Mike Pickering from Cloud Constable, and he showed us the Ava avatar, an interesting animated virtual assistant. And also Raúl Sánchez from Proxima talked about sustained machine learning project. And finally, we showed a Vulkanexus use case called serving models to ROS to robots. And for today, we have Avi Brown from Edge Impulse, and we'll discuss how TinyML brings deep learning models to microcontrollers. And also Janin Koch from Inria will show us what is and what is for human-computer interaction. So, Avi, are you ready?
Yeah, I'm ready.
Okay,
Thanks.
so if you want to share your screen, come on.
Yeah. Okay. Let's see. Um, One moment.
Okay.
I'm actually having a problem sharing my screen. I'm clicking share my screen, but nothing's happening. One sec. Oh, yeah, one
Okay,
second.
don't worry. Don't worry.
Yeah. Okay. Okay, it's letting me share a Chrome tab. It's not letting me share my screens, which might cause me problems with the demo, but we'll cross that bridge when we get to it.
Okay.
Uh, Anyway, hi everyone, and yeah, thank you so much, Lara, for inviting me
Thank you for
to
you.
the working group. Yeah, really, I'm a big fan of the things that eProxima has done with MicroROS and is doing now, and it's a real pleasure to get to be part of this. So I've most of the people here probably don't know who I am, so I'll just share a few details about myself. I'm Avi, and my day job is that I work at a small robotics startup here in Israel. We are building a vineyard robot, an autonomous vineyard robot. That's what I do during the day. And as sort of a side project or side work, I am a part of the Edge Impulse Expert Network. And I'll talk more about what Edge Impulse is later on, but it's just a platform that I really, really like working with. And I love doing projects with them. So I'm going to share a bit about them soon. And as Pablo knows, I post a lot of issues on the MicroROS repository, and so you might see me there. I hope that the things that I contribute with this project will make up for the issues that I post. But I really appreciate the eProxima's patience with helping us with issues. So thanks a lot for that. Uh, I had the pleasure of presenting at ROSCON in Kyoto just in October. It was a real pleasure, and this presentation is sort of a continuation of the things that I spoke about there in Japan. And if you don't believe me, that's me right there. So there's proof that I was there. Um, Okay, so let's jump into it. What is Edge Impulse? This is the AI integration group, and I imagine some of you may have heard of Edge Impulse. If not, I really recommend checking it out. This is by far the best solution for designing and deploying neural networks for memory-constrained edge devices. Okay, so this has up until now been a very, very difficult thing to achieve. But Edge Impulse has created a work of art in terms of the user experience for building these neural networks and getting them to run on everything from full-blown PCs all the way down to very memory-constrained microcontrollers and NTUs. So their platform supports really every stage of the machine learning operation cycle. So starting from your data collection, you can perform data collection directly from your target device. You can design your model architecture. You can build and tune your DSP blocks, train your models, test your models, and of course, deploy them finally in a vast variety of different ways. So you can deploy your models as standalone C++ packages, Arduino libraries, really a huge variety of different formats. So it's very convenient in that regard. And what does Edge Impulse have to do with micro-ROS? Well, of course, they both are related to microcontrollers, but I sort of categorize Edge Impulse and micro-ROS in the same category because to me, these two frameworks offer standardized ways of doing otherwise very, very difficult things. Okay, using microcontrollers within a robotics context is traditionally very difficult. Whether we're using ROS serial with ROS1 or especially now with ROS2, if you're not using micro-ROS, this is not a trivial task. And of course, running neural networks on microcontrollers is also not an intuitive task, and so Edge Impulse makes that much, much easier. So I've kind of put these two in the same category in my mind, and so I thought, okay, let's find ways to use them together. So you might be asking, so what? Who cares? What's the point here? And I'll talk a little bit about my personal vision for how these two tools can work together. But really, I want to do things that are useful to the community. So the things that I'll present here are my personal goals and vision, but I'm really looking forward to hearing back from people after this presentation and to hear what people think. This is kind of how I see these two tools working together. Using micro-ROS for the ROS2 communication and Edge Impulse for building neural networks for microcontrollers, you can make your own custom plug-and-play AI peripherals for your ROS2 systems. That means that I can take a board, let's say the Arduino Portenta H7, or any of the other boards that are supported by micro-ROS and Edge Impulse. There's a lot of cross-compatibility, by the way. I can take this, deploy a neural network, wrap it in micro-ROS, and this device now becomes a sort of an AI dongle that I can go and plug into any existing ROS2 system and gain the benefits of neural networks without having to worry about drivers or making it work with every different specific system's requirements. Basically, I can make my own edge robotics peripheral, and that's really a cool idea, in my opinion. So you might ask, well, why run these neural networks on a microcontroller? Why not just run it on the main ROS2, let's say a Linux single board computer? And my answer to that would be, if you can, do it. I'm not here to convince anybody to force anybody to use their neural networks on a microcontroller. And of course, there are a lot of neural networks that are so big and so demanding in terms of resources that using them on a microcontroller is probably not practical and not the best approach. I will say, if you do want to run a neural network on, let's say, a Raspberry Pi or a Jetson board, Edge Impulse can do that too. So Edge Impulse is not constrained to microcontrollers. And in the context of ROS2, one good project that exists is the Nanosword project. This is a ROS2 project created by a guy named Raffaello from NVIDIA. He has done a ROS2 and Edge Impulse integration using a NVIDIA Jetson board. This is not micro-ROS, but it is using Edge Impulse and it is using ROS2. So if you're interested in that, I really urge you to check out the Nanosword project. But beyond this, a reason why you might want to run your neural network on a sort of peripheral microcontroller is that the RAM on your host computer, your main ROS2 computer, is very valuable. And when you start to introduce things like high-frequency sensor ingest or running multiple inference networks, these can introduce very heavy loads to your system, and it might not be practical. If you're running a Raspberry Pi and you start to pile on neural networks, your system will quickly become bogged down, and so you might want to take this sort of more distributed approach, which this sort of integration allows. In this case, the limit to the number of neural networks you can run is the number of serial interfaces you have. If you have a few USB ports open, maybe a couple of UART ports open, each one of those can be used to communicate with a peripheral device. And that can give you a lot of flexibility in terms of the number of neural networks you can run if you have a complex system. And that's also really exciting. So you're no longer limited by your memory, more by your serial sort of capabilities. And also, this offers a high degree of modularity. Like I was saying before, if I train a neural network and have some sort of functionality running on one of these devices that I designed, I can go and plug it into any ROS2 system, and it will work. As long as that ROS2 system is running the micro-ROS agent, it's compatible. So there's some existing work to this end. The thing I mentioned before, the Nanosor project, you can just search Nanosor online, and that's Raffaello's work. I didn't list it here because it's not specifically related to micro-ROS. That's more, ROS2. But I have a repository growing with examples, currently only with the Arduino Portenta H7 and the Vision Shield, which is a board that's officially supported as well by micro-ROS. I have C++, like proper C++ examples coming for the Raspberry Pi Pico, and with the ESP32 coming soon. I'm still working on making it organized and user-friendly. So I haven't posted it yet. But the examples that I have for the Arduino Portenta, I have two different examples. I have a camera example that does image classification. Basically, this board takes images and can classify and make predictions about what is in the image. And a microphone example, which you can train a neural network to recognize, let's say, keywords or voice commands, and it will run the neural network in a loop and make predictions about what words are being spoken. Now, I want to show a quick demo, and I really hope I can get this screen share to work. And I'm going to try real quick to stop presenting here for a moment just to see if I can get it to work. Man, it's only letting me share Chrome pages. That's really annoying. I don't know why. I don't know why. I'm thinking I would love to show a demo. But if it's not going to let me, I may just talk a bit about it. If anybody has ideas about what I could try,
yeah. Are you using Wayland? I mean, the default Ubuntu 22 visualization?
Yeah.
Yeah, if so, there is a problem there that you have to activate something else in Chrome in order to share the screen.
Okay.
Let me search for the command because I did it the other day. So.
Okay, great. Actually, while you're doing that, I'll just kind of give a quick intro to the demo, and I really appreciate that. Thank you. So I'll just talk a bit about what I'll be showing in the demo. So in the demonstration, I will show the following thing. I will start to echo this topic called the wake word publisher. Thank you, Ro. Thank you very much. And basically, I have the ROS2, the micro-ROS agent running on my Ubuntu computer. Okay, and I will try to echo this ROS2 topic. As soon as I plug this device in, this device has been trained to recognize two different words, which are sleep and wake up. Okay, any other word that is spoken, it will try to classify as background noise. Okay, and basically you will see this topic will start just streaming these predictions. So under each value, under each term, there is a value, and this value is the percentage of how confident the network is that this word was spoken. So in this case, it's 98% confident that the word sleep was spoken. So I will try to get this working, and I see.
You just have to copy that in a new tab.
Okay.
And then enable the first. The first thing that.
PC.
Yeah, enable that.
Okay. Nice.
And then restart Chrome.
Okay, so I think that will probably kick me out of the meeting, but I will just rejoin quickly. Thanks for your patience. Okay, I'll try this now. Okay, let's give this a shot. I'm going to share the window, and looks like this will work. So you should see now my terminal. Do you guys see that?
Yeah, sure. Yeah.
Okay. So it's trying to echo a topic. I have not yet plugged in my Arduino, but once I do, 1 second, the micro ROS agent is running in the background, of course. And once I plug this in, just over USB, I should start to see, yep, and here we go. So it's starting to echo the results of the neural network, okay? And so I'm not saying any of the key words, but, and so everything is being classified with high probability that it's background noise. But if, let's see what happens when I say one of the words that it was trained on. So I'll try sleep, 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 and I'll try the other word, wake up, sleep, wake up. And I hope it's the update, it's clear from the video that the numbers are jumping up to close to 100% confidence for each of those times. And of course, I can just unplug this, it will stop streaming and plug it back in, and it just kind of picks right back up. So this is nice because I can just take this sort of dongle that I've created, right, and plug it into any other ROS2 system, and it will work. I can add voice commands to any ROS2 robot. Obviously, I can access that network, access that topic from any sort of ROS2 system. And I'm just going to go back to my slideshow here and do this here. Slideshow. Okay. We present a window. Okay. So I'm just going to quickly, to finish up here, run through a few different examples of applications of this kind of integration. So one, let's say you're using a microphone as a sensor. You could do a sort of wake word or keyword spotting voice command dongle, just like I showed here. Another potentially interesting application is to perform predictive maintenance for a mechanical system. Let's say you could train a network to recognize, let's say, gear slipping or some sort of like electrical hum. There's all sorts of different applications for predictive maintenance that could be relevant for, let's say, a more industrial setting or something like that. For a camera sensor, you can perform image classification, and I have an example for this for the Arduino Portenta Vision Shield. And Edge Impulse has a really kind of innovative way of performing high-frequency object detection with something they call FOMO. I don't have this working yet with microROS, but it's just because I haven't started working on it yet. I think it will be straightforward. But this is really cool. It's a really interesting approach to performing fast object detection using a microcontroller and a camera. So I recommend checking that out. And let's say if you have an accelerometer as your sensor, you could use vibrational data to train a neural network to recognize different types of terrain. And this could be really interesting for, let's say, mapping terrain in RViz2. You know, you could train the network to recognize dirt or asphalt or, you know, a smooth tile, and add sort of an extra layer of information to your maps. And also on the topic of sort of predictive maintenance or anomaly detection, you can train a neural network to recognize, let's say, you know, a motor that has gone into oscillation or some sort of problematic vibration onto your robot. And, you know, this might not be functionality that you would add if it would cost you RAM on your main computer, but when it's just a matter of plugging in an extra device, you know, this becomes sort of a straightforward decision to make. You're gaining a lot of benefits from an otherwise pretty simple task to perform. So my goal here is to give back to the community. These are things I do in my free time. I've gotten a lot from the ROS2 community, and this is my way of hopefully giving back and creating something interesting. So I would really love to hear from the community. If you guys have ideas of interesting applications or ideas to collaborate, or maybe you want to make contributions. I have one guy working right now on adding some functionality to the repository, I would really love that. And so even if it's just a note saying, hey, this is interesting, or hey, this is stupid, send me a message on LinkedIn, and I would really love to hear from you guys. And with that, yeah, thank you so much. Of course, if there are any questions, I'd love to hear them. But as far as I'm concerned, I'll stop there.
Thank you very much, Avi. Amazing, the talk. Okay, Helio, go.
Hi, Avi.
Hi.
This was a very interesting presentation, and I really like the idea of having a modular way of adding AI-enabled components to a ROS system. What I sort of missed there was some looking to the API. I know that there is a micro ROS component that's doing the interface on the ROS level, and there is an AI component that is controlling how the model is being loaded into the microcontroller. But I would like to see how these two work together. Is it just like a ROS node where I pass some parameters with some information on which device I'm controlling and with the path to the model, and then it's automatically loaded to the device, and it starts publishing node and starts publishing messages, and it all just works?
Right.
Is there a programming element involved where I need to write a wrapper node and so on? So how would it work?
Well, thank you for the question. And yeah, I didn't go into the code so much, but basically there are two main things you need to perform. First of all, Edge Impulse, the output of an Edge Impulse project is a self-contained model. So all you need to do is basically import this model into, let's say, if it's an Arduino project or something else, they have a whole C++ SDK. You import this model, and then you can access the sort of inferencing engine for your specific model. Okay, so that's one thing. And I've made a custom, the demo I showed that has this sort of result message being sent. It has a result, label, and then percentage values, right? This is a custom message type that I made, custom micro ROS message type that I made. And essentially what the code in the examples that I shared is doing is it's just taking the inference result from the Edge Impulse library, okay, and loading the results into this sort of inference message type for micro ROS. And then as far as the micro ROS node and everything, this is just standard a standard micro ROS publisher node, just like any other of the micro ROS nodes that you'll see on their examples. And so, yeah, and I will say I made it on the examples. I made it so that you don't have to do any special like changes to the code for memory allocation. Let's say your model, your word recognition model has 10 words instead of 2 in my example. It will automatically allocate enough memory to make the message size the right size. So yeah, I also have a tutorial on YouTube for the camera example, and there I go a bit more in depth in the code. So feel free, I have a link to that in the GitHub repository, and you're welcome to take a look.
Okay, thanks.
Thank you.
Anyone else? Okay, so thank you very much, Avi.
Thanks, Lara.
Amazing. And now is Janin. Janin turn. So Janin, are you there?
Yes,
Yes.
1 second.
Okay, no problem. So it's your turn.
Yes, so I will present together with Wendy McKay. Let me see how I share my screen here.
Okay.
Probably the same problem as Avi before me. Let's see. Wait a sec. Yes, share screen. Let me see. Hide sidebar. Share windows. entire screen. Ha! Here you go. And share. Let's see if I now put that on full screen. There we go. I think that should work. I think you can see my screen, can you?
Yeah.
Yes, sorry.
Perfect. Okay, so I think, Wendy, can you say something?
Yes, can you hear me?
Perfect. Yes,
Good.
you do. At least I do. So I think, yeah, from us both, hello. I think it's the first time we both present to this community. I guess it's also very different from what Avi just presented, because I think we both don't really work with robotics or hardware. Nevertheless, we were asked by Lara and Raul to kind of present a little bit what we both are doing, which is human-computer interaction. You will hear more about that. And we also will show an example afterwards of how we apply that to one of the projects called Algebraic Machine Learning, short ALMA, which I think was also presented here a few months ago, when I'm correct. So some may be familiar with it, but I will give a short definition in case you have missed that. But I think I would like to hand it over to Wendy now, because she will actually start the presentation.
Okay, and I'm not entirely sure if we each have our slides separately. So
No, I put everything
them
together.
all together. It's all in there. Okay, good. So my name is Wendy Mackay. I'm a research director at Inria, which is the French National Research Laboratory for Computer Science. And I've also, this past year, been professor of computer science at the Collège de France. And my background is a combination of experimental psychology and computer science. I did my PhD at MIT, and I've worked at Xerox PARC and various other places over my career. I have a number of different research themes. My career is really long. I've been doing this for over 30 years, and so there's a lot to say, so I won't say a lot other than to say that we've been working on generative theories of interaction. And we have a recently published paper at Tokai, the Transactions on Chi for ACM, which explains a lot of that. I do a lot of work with research and design methodology. And then, of course, we do lots and lots of work with creating interactive systems. I have a long background in interactive video, tangible computing, which is not the same as robotics, but at least dealing with physical computing. We did a lot of original work there in the 1980s and 90s. More recently, I've been doing a lot of work with creativity support and have been involved with Janin on some of that, but we've also worked with musicians and dancers and graphic designers and a variety of different creative professionals. And then finally, a lot of work recently on human-computer partnerships, which I can explain. So I guess you have your hand on the screen, so we're going to shift over to Janin, and she's going to introduce herself, I think. Or how are we going to do this?
Yes.
Yes.
So, so hello, my name is Janin Koch. I'm an assistant professor at the X2 lab. So basically, Wendy is my boss, but I think we basically work together more. That's more the relation. I'm also an HCI researcher. I actually have a background in management and data engineering, as well as interaction design. So I'm coming actually from the more from this side. The focus on my work is mainly on human AI collaboration for exploration. That means everything where human and computer can work together to explore things they really, they, for example, don't know, that might be ideas, that might be concepts, models. I give some examples later on. And the domains we are working with, as Wendy just said, a lot. We are working a lot with creative professionals, like digital artists, as well as design professionals, graphic designers, interaction designers, and also more technical professionals, for example, machine learning experts. And so Wendy and I are very much interested in, for example, the agency that we can actually design between a human and AI system when they actually try to work together. We, for example, do that in human AI games and try to find out what makes a person feel more agency in an interaction with the system. How can we model that? We also work with graphic designers on how you can actually explore fonts and for certain poster, for certain visual design of your website and so on. And the last part is a project that Raul Lara is also involved here, as well as Wendy, is about how can machine learning experts actually be supported to explore different model alternatives and, for example, be made more aware of sustainable alternatives in machine learning approaches that exist. And that is just like a small snippet of like work that Wendy and I do overall. And with that, I will hand over with how do we actually interact with computers?
Yes, I wouldn't say I'm your boss. We work together, and you're in my research group. So
yeah.
So anyway, basically, I want to say a little bit about human-computer interaction, because it's not about making pixels look pretty on the screen at all. There are graphic designers who can do that, and of course, it's much more complex than that. But in our field, what we're really interested in is the whole point of how do we interact with the computer. So we have different ways of thinking about the relationship between a human being and a computer. One is we can think of the computer as a tool. So it's as if I'm picking up a hammer and I'm, nailing something down. And a lot of human-computer interaction, particularly historically, has been about the idea of how do we create powerful tools that empower people to do things they couldn't do before. The second one, which is more typically how you think of AI, is the idea of computer as a servant, where you delegate things to the system. It goes off, it calculates some things, it comes back, and it's done something for you. And the third one, which I won't go into, is basically the computer as a medium, which is this notion of mediated communication. So if we click to the next one. All right, so this is actually animated, but it doesn't need to be. You've just got the PDF of my slides, so that's fine. But the idea is that from HCI's point of view, we have to think about human skills, perception, cognition, action, all of those kinds of things. And we have to think about system capabilities and storage and calculation, input, output, all those things the system can do. And that's anything from, a laptop with a keyboard, but also gesture-based interaction, freehand interaction, large wall-size displays, very small things, tangible computing, and so on. So there's a wide range of different system things, and we have to make the match between the human side of it and what the technical capabilities of the system are. But more fundamentally, it's not one or the other. There are psychologists and sociologists who study people. There are engineers who develop new kinds of technology. What we're most interested in is this thing underneath, which is interaction, which we treat as a phenomenon in its own right. We are interested in the interaction back and forth, fluid as possible, between the human being and the system. So next. Right. So from my point of view, in human-computer interaction, our fundamental focus is on the human. And the next one, and that's somewhat in contrast to the AI approach that we get, at least how AI is taught, and a lot of the AI research is published, where the focus is on the machine, the thing that's built. And of course, in your case, you're mostly thinking about robots, but it's building algorithms for supporting that. So you also have this notion of interaction, but in a different way than we think about it in HCI, because we're interested with interaction with a human and a system. So it's the human plus the robot and that interaction. So we can think about computer as a tool that augments human capabilities, and we can think about it as a servant that takes over certain tasks. But the idea that we're actually exploring right now is what we call a human-computer partnership. So the two of them are taken into account at the same time. And the real challenge is, how do you keep the user in control of that? Janin mentioned a little bit before about agency, and sometimes people do want to delegate tasks completely. Sometimes they want to take it over themselves, and sometimes they want to have shared control. So next. Next. All right, so we have to be careful about not having an AI perspective that's sort of like, here we have Charlie Chaplin in modern times, and it's sort of like becoming the cog in the wheel, the user as basically this annoying thing that messes up your algorithm. So we want to think about the user not just as a source of data that we model or who contributes information to the system, and treat them as just components of the machine. Next. But rather okay, so that's what we want to avoid that. So one thing that we do is when we look at the term human in the loop, We on the HCI side would argue that that is actually a problem. That is treating the human as if they're a cog in the wheel. That means they're a gear, they're part of a machine, but not really a human with their own agency. So one of the things that happens is you see how our interaction, this is just a really super simple example that all of you have seen, I'm sure, which is you want to have an intelligent agent that is designed to help you, but what it actually does is it changes your role as an author when you're typing in a text messaging thing to, next example. So here's an example that I kind of like. So you say, just so you know, Dad's in prison. And the reaction is, what? Are you joking? Are you answering your phone? I'm freaking out. And then a little bit later, the person comes back and goes, oh, I'm sorry. Just so you know, Dad's interested, sorry, in the bathroom. Dad's interested in dinner tomorrow. And the other person says, you just took 5 years off my life with that autocorrect. And one of the things that's happening is as users, in this kind of interaction, we stop, when I talk, I can just speak. But when I type something and the system is interrupting me and saying, oh yeah, you meant not dinner, but prison, then what it's doing, and then I have to pay attention and start auto-correcting for the system. So we have to pay attention to the kind of roles that we're creating in the interaction between humans and people. Yes, between humans and systems. Next slide. Okay, so it's really important that we understand that the same algorithm with the same interaction may have a different result. So the answer is not just finding better algorithms. And also the same algorithm with different interaction may produce different results. So it's not a one-to-one correspondence between the quality of the algorithm and the quality of the interaction. Next slide. Okay, so the human-computer interaction perspective is to always think about things from the perspective of what is the impact on the human being? Can we create interactions? Not just can we create cool algorithms or cool systems, but can we create interactions between humans and those systems that benefit the users? Can we empower them? Can we give them more skills? Can we allow them to control the system? And one of the things that we're particularly interested in is the idea of not having intelligent systems that de-skill users, but rather by combining human beings with intelligent systems together, both are better, and it improves human skills over time as well as improving the AI skills over time. So that's what we mean in human-computer partnership terms. I think I want to keep going. Yes.
Wait.
It's coming.
Yep.
This is a shared, this is delegated control. Janin is being the machine for me. Okay, so instead of treating people as the source of data for your algorithm, we're arguing that you need to click. When I do this, that means click. Consider the algorithm as a source of information for the user. And how do we do that? And it's not just explainable AI in the sense of explain what happens in the algorithm, but really explain to the user in the sense of informed consent, to give people an idea of how the system is interpreting their behavior and how they can modify that and change it to do what they want. Next. Okay, so what we want is human-computer partnerships. I'm going to define that in a second here. So we want to take advantage of the best features of each. So one example is I can delegate control. So I take a taxi. Say it's Saturday night, and I got a little drunk and I want to go home. I can tell the driver, you take me home, and I don't have to worry about it. I delegate the control to the driver. But in the next example, we can have a different kind of control, which is that I want to maintain control. I want to become an expert. I don't want to just be a beginner all the time. I want to learn how to drive a motorcycle. I can go out and have fun and play with it and so on. And in that case, I want to stay in control, but I better not be drunk, okay? And the third one is the thing that we're most interested in, which is to think about a different kind of transportation, this idea of the horse metaphor, the H metaphor. But the idea is that we want to share the control. The human being has a different form of intelligence than the horse. And if I'm drunk and it's Saturday night, the horse knows where we live and will take me home. But if I want to go out and go jumping or do fun stuff with them, I can do that. And over time, we learn together. The horse gets to know me and I get to know the horse. And so to me, the ideal intelligence system is not one where I delegate all the control and I'm basically sitting in my Tesla and it gets me there, but rather, and I don't necessarily want to drive a Ferrari all the time. What I want is the ability to make that choice at any point in time. So next. All right. So the idea is that if we're going to create human-computer partnerships, we want to have a fluid shift of control between these different forms of agency. And I think there's the, yes. A last thing I wanted to say is that as AI, if you look at the AI research literature, the way that success is measured is by the quality of the algorithm. Did that algorithm perform better? Without necessarily asking the question about users. From an HCI perspective, we always have to ask, and what I call computer in the loop rather than human in the loop, is the user better off? And of course, we can ask both questions. It's not like it's either or, they're not really in conflict with each other, but it's really important for both communities to recognize that there's a different value system and a different tradition in how you publish, and that we need to do, if we're going to do human-centered AI, we have to take both of those into account. And I think that's where I hand it back to you. Oh, well, yes, I did got one last thing. Better algorithms are, go back one more. Yeah, better intelligent algorithms are neither necessary nor sufficient for creating intelligent systems. They're both good things, but they're not sufficient. And then there's this notion of expressivity and so on. And I hand that off. Yeah, we want systems that are discoverable, appropriable, and expressive. And we'll focus on expressivity right now. And that's Janin. Right.
And I think that's actually quite a good start to that. So what I will now present is basically some work we have done in one of the projects called ALMA, human-centered algebraic machine learning. And it is about situated typing. So for everyone who wasn't here for the ALMA presentation, just a quick reminder, algebraic machine learning, also abbreviated as AML, is a machine learning technique based on algebraic representation of data. It's unlike statistical learning, which is rather common nowadays. AML algorithms are supposed to be rather robust regarding the statistical properties of data and are parameter free, and beyond that are actually kind of considered white box algorithms, meaning that they actually we have the ability to understand why, for example, certain decisions were made, for example, in the case of classification, which parameters actually led to this decision, which, for example, from an HCI point of view, we can use for explainability. And the example I want to present is situated typing. But first of all, I have to present what is actually situated typing, what is actually gesture typing. This is where it comes from. So I guess most of us actually own a smartphone, which has nowadays quite often by default a gesture keyboard provided, which basically lets users enter text by drawing a line that connects all the letters in the word. So we have a word gesture. Now, word gestures are usually basically mapped against a combination of different models to kind of predict the most likely word that you wanted to gesture without using different distance matrices, language models, and so on. However, the gesture that you do, that I do, that Wendy does, and that Lara does, for example, can differ quite a lot, even though we write the same word. Now, because these gestures actually contain way more rich information about, for example, intents or situation, like handwriting would do. However, because we are so focused on actually presenting the right word, we kind of discard all this information and basically are left only with the part that is the word itself. So, and what we wanted to look at is could we use, for example, models like algebraic machine learning to kind of use these diverse gesture aspects to kind of represent them and give that back to the user to actually play with it, to explain things, to actually represent, for example, the situation they're currently in. And that's how we got to situated typing with algebraic machine learning. And how it goes beyond gesture typing is that we actually think that we can use algebraic machine learning to provide real-time classification of not only the intent someone has, based on the type of gesture. For example, if I'm very elaborated, or if I'm very fast, for example, I might be in a hurry, as well as, for example, taking information about the situational environment and basically letting an algebraic machine learning approach kind of classify that and translate that in, for example, color or expressive font that the user can actually use to express themselves to other users that they have. Now, how did we do that? Of course, everything starts with data collection. We did within participatory design studies, within participant studies, with 11 participants, we collected a number of gesture-typed phrases over 5 different days, which is more than 14,000 gesture typing data, to kind of gather enough data between, for example, the situation someone is in, if someone is sitting or someone is walking while typing, as well as how expressive someone wants to be, like one rather quick, like I don't really have time for that now, or rather exaggerated, like, you know, this is super nice. And the idea was like, can we actually build an algorithm that can learn and represent that in real time? And also beyond learning, actually allow the user to feedback why the system made a certain decision and how a user could, for example, adapt their behavior or actually change their behavior to kind of make themselves better understood to the system. And so, in order to train this algebraic machine learning model, we first had to pre-process the data. For example, as you can see here on the keyboard, someone typed very quickly a word. I actually don't know which word that is right now. And so basically we gathered data about the X and Y coordinates on the screen, and then, for example, calculated certain features which are meaningful for the user. Now, here's the thing, something that is very important for HCI is if you actually want to enable people to understand what the system actually does, we also have to think about what can a user actually understand. So while we of course can measure acceleration, the measurement of acceleration to be controlled by a human is actually very hard. So we actually turn to things like for example, also curviness and speed in combination with aspects like acceleration, which can be rather better understood by humans, which we actually tested in previous work that I haven't shown here on gesture typing. We then actually built an AML embedding. I will not go too much into that, but we basically divided these features we had into 16 bins using k-mean algorithms. I think for people who have heard a little bit more about the algebraic machine learning talk, I think that was way more about the embeddings and how they actually impact the algorithm. And basically, in the end, evaluated that against existing algorithms, for example, on how good they could classify, in this case, for example, the situation someone is currently in. And that kind of, this kind of allowed us to say, okay, depending on how you actually write your gesture, we can classify if you're currently walking, sitting, or doing something else. And we can actually represent that by, for example, matching it to color schemes. Basically, if you're very calm, the color would be very blue, or if you're like running around, the color would be red. So the person who receives the message does actually learn way more about your intention in your current situation while you're typing beyond the text that you're actually writing, to kind of transmit more information. And based on that, we actually built a prototype using Android models, an Android phone, where basically the raw positions of the gesture keyboard here are streamed to the AML model. The AML model then provides basically the feature values and the confidence level, saying like how confident it is that you're currently sitting or walking. That impacts how strong the color is, for example, very red, very blue, or very green, as well as how expressive you are, which actually was translated into the font. So for example, when you're very expressive, it would be like here very like joyful, childish fonts. If you are very quick, this would be more like a handwriting font to kind of visualize also to your receiver in what situation you're currently in while you're writing that. And actually, what we're currently working on is also showing how the algorithm actually understood the different features and to give kind of a better understanding also for the user what happens and what the system understands and how it could be adapted. This resulted in different prototypes that we're currently evaluating in a study where people could write on a mobile phone, which has the system live running, connected to an AML model, to kind of like try out the understanding and explainability as well as the expressiveness of these kind of approaches using human-computer partnership ideas. And with that, I would like to thank you for your attention. And I think that kind of finishes our talk within 20 minutes. Kind of. And yeah, I think we are both open to questions. I know that's not probably the most common talk you have here, I kind of assume, but yeah.
No, very interesting, Janin. Wendy, very interesting. So does anyone have any question?
I have two questions. Oh, sorry, somebody has already raised their hand, but I'll ask them quickly. The first question is, I'm curious just if there are certain industries or certain fields that you think are most in need of some HCI consultation. If there are certain areas that are the biggest offenders in terms of these principles that you've outlined. That's the first question. And the second question, just on a technical level, you mentioned color and font for the prototype you developed. Are color and font both drawing from the same sort of features? I think I understood the color aspect. I'm curious how you draw things like font, which seem to have more to do with like intention.
Can I answer that one, Janin? Because that comes out of the original stuff that we did. And so first of all, we did color initially, and which we mapped curviness and variation in speed and the extension, the boundary size, the inflation to R, G, and B. And so we could get a whole range of colors and people could learn how to do it. And there's a lot of interesting things about how people learn to write that way. We also worked with a professional typographer who created a series of fonts that are separated. I think there's 16 different variations of them. And so you can go progressively from small to large. But the point is not that we're trying to interpret as a machine the expressivity of the user. What we're saying is that human beings are already expressive when they make these different gestures, and that there's different kinds of variation. The variation could be because I'm in a hurry, and this is why we did walking versus sitting. This is why we did, moving versus static. So walking, stopped, and then sitting, standing. And so you can see these differences, which are different than I'm intending to be very expressive. And so I really want to show something. And so the idea is that what we're doing is letting people in the context of their daily use show different levels of things. Just as if I write handwriting, my handwriting is different from Janin's, but I can try to write more carefully or in a really fast way, and you'll be able to tell that difference. So other human beings can tell these differences, not necessarily another machine, which I'm not entirely sure is what you're asking. But
one thing I could also add to that is, so we trained the model based on the human data. So we basically use all the features that we have. And so basically we, when we collected the data, we actually told them that, write rather expressive or less expressive, rather quick or not. And basically we trained the model on that. And as Wendy said, it's like we have basically sets of fonts in different degrees, basically from a standard font to a very, very joyful font. Like we have 10 different degrees, which were actually designed for this project. And basically based on how confident the algorithm in this particular way, in the how you actually measure the, like, for example, the intent, like how quick or how curvy it is, basically the confidence then decides how strong basically the font will be adapted. Maybe that answers your question. And I think to your first question, maybe industry-wise, I mean, we all have used very bad interfaces. I mean, I think that's nothing new. I think what we are basically arguing for, especially, is that we see more and more, I would say, more complex and AI, like tools. It doesn't have to be AI, but let's call that AI. Let's say complex tools. And coming into the market, coming in more to the end customer, which, for example, are professionals or not. And I think if you think about that, maybe you or your friends are working with a system, we actually say that we cannot just think about the system perspective, like how stable is it, how good does it run, how well does it collect data, but also think about the human that actually will use it. What is her perspective? What can, like, how can the human, for example, see this tool and reuse it? Because I think actually what we often argue is it might look like it would limit system, but actually it makes people quite often more able to appropriate tools, which then can up in super interesting ways because you give some kind of agency back to the user. And I think we see that in different domains coming up. We see that when doctors have to deal with AI tools for recommendations, when you work also with pilots, the students in a cockpit where you have like more and more complex autopilots that in the worst case are literally turned off because the human doesn't understand it. So I think there's a lot of domains where this starts popping up. Currently, it's still a lot for professionals, but it more and more also enters the realm of like everyday users, where we have to consider like non-trained person that knows how to use a system instead of like more like emerging in the interaction.
I want to add a thing. You were asking about which industries, and so things that we've done two big extremes. One is creative professionals, which is musicians and dancers, or choreographers more, graphic designers, people who do creative stuff. And then we work in safety critical systems. So, there's the pilots that we're dealt with air traffic controllers. We're currently dealing with the energy grid and now how you operators in there. In both cases, the thing that's interesting is that the artists on that side tend to create tools and appropriate them in a really interesting way. And they push the limits of the technology. And so these ideas are really good for helping us understand how to create these really more advanced fluid types of interaction. On the other side, you have people who are responsible for the lives of other people. And when AI systems get introduced into those situations, there's a lot of potential issues in terms of who has responsibility, who has control, and all of that. And so here we're dealing with a much more constrained, highly certified, really rigid structures, but we still have the same problem. And a lot of the operators, pilots, doctors, I've done stuff with people in hospitals, variety of different situations where you have highly trained professionals who are starting to be in a situation where they need to deal with intelligent systems. And there's a backlash in some cases, or there's different things. And our argument is you have to pay attention to the interaction. It's not just the algorithm. And there's some really major disasters that have happened when they haven't thought about the interaction, and then some other nice success stories when they have. So I think it's across all industries. Our particular expertise is in this sort of creative thing. And I would include data scientists in the creative professionals in the sense that they're having to figure out how to create something. It's a highly trained and it's not just musicians as creative. And then the other part is the safety critical. Those are both areas where I think there's a lot of interesting ideas here.
Does that answer your question, Avi?
Yeah, it does. Thank you very much.
I don't know who was first. I think it was Georgios.
Yes.
Yes. Okay.
Thank you for the presentation. Two questions. The first one is like the models that you derive, like, for example, how fast someone types something or what type of curve he makes for a certain word. I guess this should be personalized, right? Because with how fast someone writes something, for another person might be like common sense or like common behavior to just
Yeah, so I agree. So here's the thing. First, it was kind of, we had like two goals with this project. First of all, try if we can actually use AML fast enough to kind of run systems, as well as can we actually extract enough understanding from the prediction of the model to kind of feed back to the human what actually happens, how the model interprets, how they can change it to create this interaction. We actually used a quite diverse set of people, and actually we can see that already in the statistic I showed about the accuracy. It is also quite noisy because, as you just said, exaggerated is actually interpreted differently over people. So we have this huge set of data, and we kind of trained it with that and saw now that it actually works, as well as we can, you know, it's like also from a technical point of view, we are fast enough to run it, people can interpret it, reflect what the system does. And the next step, which we actually planned.
A note to that. So when we did the very first version of this project, what we did is we were trying to figure out what can we detect and what is the most easy to differentiate that people can do. And so we came up with the most common things that varied across individuals were the curviness, the inflation rate, and also the variation in speed, not the speed, but the variation in speed. So if I go slow and then speed up and then it goes slow again, it's that varies. And so that got built into the original one, but the original algorithm was very noisy. And so one of the things we're trying to do is to try to rethink how to do this with ALMA and play out different things and so on. But there is a lot of individual variation, but that's part of what we want, not what we're not trying to get rid of that variation. We're trying to make sure that we can capture it and express it, which is a little different than the normal way that we think about it. We did this project originally with people from Google, and who are really good at the algorithms. And one of the things, stories I like to tell is that they test their algorithms with the gesture typing with 1 million simulated users. And we initially had 12 real users, and they found new different ways of doing things that were unexpected to them with our little batch of 12 that didn't fit into their simulated millions. And so there's something about, part of what we're trying to do is just demonstrate that working with actual human beings has some real benefits in terms of this stuff.
So to kind of follow on to that, the initial project Wendy talks about actually was based on heuristics. Right. Then this one is actually based on AML, and right. The actually follow-up, maybe in a year we can come back, is actually to, as you just said, basically build that more in a basically reinforcement learning style approach. So basically allowing the system to kind of adapt itself then to the way the human writes. So for example, if my variation is smaller, it could still recognize that, but the system could adapt to that. So this is basically what we want to move on to, also with AML, but that's like now, like the idea for this year working with it. So yeah, that was the first question. And second?
Yeah, the second one is a bit more broad, but I would like to know what is your opinion on ChatGPT, which is like, there's quite a hype right now. And since we're talking about human and machine interaction, yeah, just in general, your opinion. Does it really improve things? Like,
it's a great source of creating bullshit.
Okay.
Really elegant bullshit. And
Okay.
the problem is about interaction, because if you are creating these things that look as if they're correct and real, then you can create all kinds of problems. But there are ways of using it and interacting with it that could be very productive. So it isn't about the algorithm, it's about our interaction with it. And if our interaction with it is done in a way that makes it productive, great. And if not, then it's bad. Janin, you want to say something? I jumped in.
No, I mean, I think it's ChatGPT is a very powerful tool, but I think you have also seen, I mean, there's a number of text generative tools right now, like also Galactica, which kind of disappeared very quickly again. I think there's, I think coming back to our perspective is there's this idea of I give a prompt and the system actually kind of creates the text. Well, some people actually criticized, less with ChatGPT, but it's also how it's used, that, you know, sometimes it makes sense, sometimes it doesn't make sense. You have to work with it. Now, if you would think it from the other side, if it would be using in a way that you would actually more interact with the model in a back and forth, you potentially actually would get better results. So I think taking this human interaction perspective on ChatGPT would actually make it more powerful, because the tool is very powerful, but it's basically very hard to tame, because it has like a certain type of agenda it follows. Now, when you write a text, you have your own ideas. So actually making it more useful would actually make it more interactive, because then you could actually adapt to the system, and potentially the system could adapt to you certain preferences. I mean, if you look at language models, there are actually ways to kind of adapt certain parameters to kind of improve these kind of things. On the other side, we're not experts in ChatGPT.
No.
I can just tell you.
Okay, thank you.
We're losing people, I guess. Is there,
Yeah.
what's timing?
Helio?
Yes, Helio, I think, has a question.
Yes. Last question maybe for today.
Oh, yeah.
Sorry.
So I found very interesting the metaphor of human-computer interaction as horse riding, where the horse and the rider, they share control, and they at times the rider delegates control to the horse. At other times it takes it a more tight control. I think to the problem of large automated systems like airplanes or power plants that are built to be to largely operate themselves, but when something goes wrong, the human operators who are supposed to intervene, they have very little time to get the context of what's going on, and this is a factor in accidents. And I was wondering if how this work on human-computer interaction could be used to improve on these situations, on these scenarios.
This is precisely the focus of, I mean, I have two projects right now. One is called Smart Cockpit, and the other one is working with pilots in Air France and Airbus eventually. And so the question is, how do we maintain, so you figure out what people are good at, and you figure out what the system is good at, and you try to create an interaction where you have people doing what they're good at and not what they're bad at. And one of the things people are really bad at is monitoring a situation. So trying to keep track of things. That's why we have alarms, that way we wake them up. And a completely terrible design of an automated car is one where there's the expectation that if the system, if things go so badly wrong that the very smart AI system that's normally driving can't solve it, then you ask the user to jump in. You're basically guaranteeing accidents, or at least encouraging accidents, because that's not how human beings go. And if you look at what's happening in the cockpit, and I have a student who's just been studying pilots and just gave a talk on this last week. But what's happening is that they have all kinds of indicators, and they have checklists, and they have processes that they go through to keep the human busy and to give them control over what's happening, or at least an understanding of what's happening. And they like to feel like they're in control. And then if there's confusion over what's happening with the computer, which is the autopilot in this case, they turn the autopilot off so that they are flying the plane. And there's problems with that, because if there's, smoke in the cockpit and it's dark at night and it's raining and there's other things going on, then you want all the help you can get from the system. You don't want the immediate reaction to be, I don't get what's happening with my plane, turn it off. Because you may not be able to get out of it. And there's this whole story of the MCAS intelligent system that was put in by Boeing, and there were 2 crashes with the 737 MAX, and this whole thing about that. And the problem is the pilots did not understand and did not have enough time to react. So again, it's about designing the interaction. It's about figuring out what users are good at. How do you maintain and improve their skills so that you use the AI to help them better understand how this aircraft is actually operating, rather than to try to take over from them and do it instead, and make the tools that allow them to keep improving their skills and keep understanding what's happening. And it's tricky. I mean, it's not like there's an easy answer here. This is why it's research. But we're getting better at it.
I mean, it also, for example, implies finding out what, for example, pilots actually are looking at when they try to understand a situation, right, and representing that. So we are, so some of the things we do is like, I mean, we actually build also systems. That there's a part of interaction, but there's also a part of visualization, basically, like how do people actually cognitively understand, for example, where an airplane currently is, and how can we represent that in a way that basically allows the system to express what it thinks it does to the pilot, but also the pilot actually somehow giving feedback on what they understand happens, so that we can avoid these kind of contrast situation of I turn off autopilot, or the system just hand over everything, go for it, but actually thinking about a way to kind of get this more like that both can figure out what happens. And like this figuring out what happens is a way of interaction, it's a way of designing a system, it's a way of visualizing. And I think that is kind of approaches we try to take in that. And as Wendy just said, like it can go very wrong, especially in safety critical systems. Another question? Or does that answer your question?
Yeah.
Well, that's a start. If I may, I'd like to contact you later, and if you could share any references or papers or references I could read into how HCI can be used in these scenarios, that would be great.
Sure.
Yeah, sure.
Thank you.
You're welcome. So any other
Okay,
question?
any question?
I mean, we're already 50 minutes over. But that's fine.
Don't worry, it's okay. This is because it's interesting, your talk. Okay, so I think that we have finished. So thank you very much, Janin and Wendy, for the talk. Very, very interesting, amazing. So, okay, let's go finish.
Thank you for having us.
Yes, you're welcome.
Thank you.
Bye-bye.
Okay, so see you guys next month. Okay, bye.
Bye-bye, everyone.
Bye.
Bye.
Bye.